An automobile engine slows down from 3500 RPM to 1200 RPM in 2.5 seconds. Calculate its angular acceleration, assumed constant, and the total number of revolutions the engine makes in this time. So first of all, you have to, in this kind of problems, to follow a little bit more abstract way, formal way, because the illustrations here usually are not so useful as in the previous kind of problems. So what you have here, you have 3500 RPM. This is clearly rotations per minute, so this is initial angular speed of the automobile engine. So omega initial equal 3500 RPM. And you have to convert this in radians per second. How can you do this? One rotation gives you 2 pi radians, and in 1 minute you have 60 seconds. So you have to cancel this. You will have 2 divided by 6, 1/3. So you will have 117 pi radians per second roughly. Then omega final will be equal 1200 RPM. Again, you have to convert this into radians per second. So you have to multiply this by 2 pi radians and divide by 60 seconds. So you will have 40 pi radians per second. And then you have to use definition of your angular acceleration. The angular acceleration is equal final omega minus initial omega angular velocity divided by the time interval. So if you put here 40 pi minus 170 pi in radians per second divided by the time interval 2.5 seconds, you will be able to calculate your angular acceleration. If you will put all numbers properly here, you have to come up with minus 96.34 radians per second square. So we did solve first part of the problem. Now second part of the problem we have to solve. To find how many rotations, revolutions, engine did for this 2.5 seconds, we first have to calculate through how big angle, delta theta, the angle will rotate. Delta theta is theta final minus theta initial. And this would be equal. You can use a different way to calculate. For example, you can use formula omega final square minus omega initial square divided by 2 alpha. You have both omega, you have alpha, so not a big deal to calculate your delta theta. And then to find number of rotations, you have to divide this angle through which engine rotates by 2 pi, because in one rotation the angle will cover 2 pi radians. So what we will have 1 over 2 pi, then you have 40 pi radians per second square minus 117 pi radian per second square divide by 2 times minus 96.34 radians per second square. And the rest is just to do numerical calculations. If you will finish numerical calculations, you will have approximately 98 revolutions. We did solve this problem.